what I would like to do now is I would like to query 1.1 petabytes of data live on stage.
We're going to do a live petabyte demo. That's perfect. I've been waiting for this moment. So in front of me, I have a peta. And I'm going to do a live petabyte demo.
Pino, no. I want to query a petabyte of data.
Wait. What?
Yeah.
I
have my laptop.
Rocky, live?
Yeah.
Rocky, this does now end well.
No.
What happens if this doesn't work?
Then I have this ghost pepper, which Tino promised that he is going to be eating if his product doesn't work.
Oh my!
So I'm just going to keep this here, and I'm going to switch over to my screen. Okay, so what I'm basically doing here is, the same architecture diagram that we're looking at. I've got SQL Server on Linux running as a container on my computer. And I've got the open telemetry collector. It's just like a Docker container. I'm just like running it on my laptop here as well. So the way the setup works, is the top of the screen. I apologize, it's a little bit hard to see. This is the open telemetry collector. And then I basically have it like reading from this file. So for example, I will probably just put in hello ghost pepper.
Oh, that's so funny.
And basically what's happening is this log is now being sent via the OpenTelemetry collector into open mirroring, like into the bronze zone of the data lake, right? It's going to be looking like a crazy looking JSON. So at that point, I've got Fabric running Spark Streaming, which I'm about to show you right now, over here, which is basically reading the data from bronze, and I'm just doing some Spark Streaming in order to convert to silver. So just to show that there's like no kind of funny business going on, I'm going to go ahead and run this notebook. So let me just go ahead and spin it up. And what is going to do is going to do a describe. Sorry, it's going to do a describe table command. Which if you work with Delta Lake before, describe table is a way you can show like the size of the table and stuff. So I'm just waiting for the Spark pool to come up, which took 10 seconds as Joanna demoed at the keynote. And I'm just going to be showing you the size of this data. So basically, just bear with me for a couple seconds. And what you're going to find is it's going to end up being about 1.1 petabyte of data. So that's my silver table right here, silver machine. This is in the lakehouse root. And then I'm also querying the warehouse root, which is going to end up being a petabyte. So if I go back, essentially what I'm going to do is we are going to query this entire kind of medallion architecture, which happens to consist of 1.1 petabyte. With the warehouse and the lakehouse endpoint. So again, looking at the tables, this is my silver table. The size in terabytes is 1.1 petabyte. And then the star schema we have is about 2.3 terabytes. Cool. So now I'm going to go over, to this notebook, which is just connected to the warehouse. And let me just talk about the business before, we're going in and running the query a little bit. So the problem statement is as follows, right? So I've got a SQL server that's running on Linux on my computer. And that SQL Server has like a Azure resource ID, like an ARM resource ID. And I'm interested in seeing what are like the logs that have been coming in from my machine. Let's say a customer opened a support ticket, right? So I need to basically go in on the Microsoft side and kind of help root cause that situation as an engineer and as an on-call engineer. And so we use Fabric for that. So, that's where we're going to be running that query. So let me look at the query, and, I did run it before the demo, which is why you can see the speed, but let me just run it again, and you will see it comes into about 1 second. Let me talk about the query a little bit. So what we're basically doing, again, we're querying a petabyte over here, but there's like a science to being like...
Wait, did you already query a petabyte?
I did, yeah. It was 1 second, yeah. So I'll query it again for you. And this is not using like result set caching or, any other funny tricks. This is like legitimately querying a table that is a petabyte. There's a science to this, right? Like if you just throw the product at a petabyte, I mean, obviously, this is just computers, right? Like it doesn't know magic.
So just to be clear, you just queried a petabyte.
I just queried a petabyte. You don't have to eat that.
If you don't have to eat it. But I'm still going to eat my pita though. Yeah.
So, we're using some of the greatest best practices that you can apply in this Delta Lake situation. So like, for example, I've got Z ordering set up. I've got high partition. One of the things you'll notice is, I'm using like 3 different partitions. Because again, like when an engineer is like looking to query data, I just need the latest logs, right? So if you structure your table and lay it out in a way where you have like partitions, that basically like allows you to like trim data out, you're going to be able to get query speeds that are this fast, right? So, I can go ahead and look in here, and you can see like the logs that, we have been putting in from my laptop, right? So you can see also the latency. The latency into bronze is 1 second, right? Because my OTel collector is writing in 1 second. The latency with Spark Streaming is about 24 seconds, and the data is available within 24 seconds. The next use case is where we have star schema users. So like PMs in leadership that has a lot of crazy joins. Believe it or not, it is a different ballgame altogether incurring one large table versus having a table and like 10 different joins. There's like a completely different science you have to apply.
Yeah.
I just know from like personal pain. So these are the kind of queries that my end users would be running, right? I've got a dimension table, so I've got multiple dimension tables. I'm applying filters into the table, and then at the end, I've got that fact table, which is 2.3 terabytes, and this is the kind of query I'm pulling out, and you can see all of these joins. So again, if I go ahead and do a run here, because I've got cluster by, so the feature that was just released like a few months ago, where the data warehousing engine basically lays out the data, I've got a clustering set up on machine arm ID and region partition, which means that these joins are basically happening in less than 1 second, right? So yeah, I think like this is
that's one of the strengths of Fabric Data Warehouse. It's really, really good at joins. Amazing. Thank you so much, Rocky.
Thank you.
Yeah.